Hey guys, this is Mr. C, and this video I'm going to show you how to solve some quadratic equations using square roots. So let me set it up here a little bit, and I'm going to think of a couple of things here. I'm going to think of 3 squared. What's 3 squared equal to? And we all know that that is 9, right? However, negative 3 squared is also equal to 9. So here we have two numbers, different. When you square them, they both equal 9, right? So if you think about it, if you didn't know this 3 right here and the negative 3, let's just say x, right? So if you say x squared is equal to 9, you have to remember here that there are two possibilities that can happen, because you have two different numbers that when you square them could equal 9. Now, right now, when I wrote this, I didn't really know that it was 3 and negative 3. So I'm going to pretend I'm a student who's just seen this for the first time. If you take the square root of both sides, that's the only way to get rid of that square right there. That's it. So if I take the square root of both sides, like this, I'm going to get, well, the 2 and the square root cancel out. And so when they cancel out, the x comes out, equals, and then that square root of 9 is 3. Now the problem here is I only get this number right there. So somehow I have to make sure I get both numbers back. And the way that we make sure that we get both numbers back is we put a little plus minus right there in front of the square root of 9. So that way we can get both numbers. Now when you take the square root of 9 and you keep the plus minus there, you're going to recover both of those answers. X equals 3, positive 3, and x equals negative 3. And that's how you read the plus minus, positive 3 and negative 3. So that kind of sets up the basic idea of the square root property. And so most of our problems here are going to just kind of rely on that one simple principle, except our x squared here that we had is going to get a little bit more complicated, but that's okay. We can take care of that with a few other operations. So let's talk about a couple problems, and let's do one like this. Let's say I have x plus 3 squared equals, and let's just say 36, for example. All right, the only way to get rid of this square is to take the square root of this, because as you've been told, a square and a square root cancel each other out. So take the square root, plus minus, don't forget it. Now, right here, I've got an issue, because if I just tell you that they cancel out, then you might believe me, but then you might not really know why that is. And so the reason why a square and a square root cancel out, and if you think about it, if I have x squared, we know that the square root operation here that we apply is really the 1/2 power, right? And so what happens is you're taking all of this, or I'm actually just using x here, you're taking all of this, and the square root acts like a 1/2 power on the outside. Well, by our rules for exponents, we know that a power of a power you have to multiply. Well, 2 times 1/2 is really just 1. And so that's why they cancel out like that. Okay, so back to our problem here. When you have a square and a square root, they cancel each other out, and really the technical term for that is inverses. The x plus 3 just kind of pops out. Really nice for us. Equals plus or minus, and then you have the square root of 36 there. Well, the square root of 36 is just 6, right? Okay, now you do need to get x by itself, so we need to subtract 3 on both sides. Those cancel out because they're additive inverses. That negative 3 right there is going to go in front of the plus minus. It always does. And we now have x equals negative 3 plus or minus 6. Well, that's going to give me two solutions. We never want to leave it like this if that happened to be a perfect square at the beginning. So what we want to do is simplify this. So we have two solutions. The first one is negative 3 plus 6. And that would just give us positive 3, right? Okay. The second solution is negative 3 minus 6, and that gives us negative 9. So let's check one of these. Let's plug a 3 in here to that x right there. Now let's forget that we took the square root here and square root here, right? the original problem. If you put a 3 back in here, that would be 3 plus 3, right? And that's 6. Well, 6 squared is 36. We got it. You can do the same thing with negative 9. When you plug that back in, negative 9 plus 3 is negative 6. However, when you square that negative 6, it becomes a positive 36. And so we now know that these two solutions are correct. Okay? So let's move on to a couple other examples. Let's do one like this. Let's suppose now we have, we'll do 3 here. 3 is a good number. Times, let's say x plus 2 squared equals, let's just say 27. Okay. We never ever want to distribute that 3 there. Never want to do that. What we want to do is divide both sides by that 3 right there. So if you divide both sides by that 3, these cancel out because they're multiplicative inverses. We bring down our x plus 2 squared, and 27 divided by 3 is 9. Now that's nice because 9 is a perfect square, isn't it? So now we're going to apply the same exact process we do every single time. Take the square root, plus or minus, don't forget it. The x plus 2 comes out, and that equals plus or minus 3. We're going to move that 2 over, and now x is equal to negative 2 plus or minus 3. So we now have two solutions going on. The first solution is going to be negative 2 plus 3. Well, negative 2 plus 3 is just 1, right? And the second solution is negative 2 minus 3. And negative 2 minus 3 is negative 5. And there's our two solutions. You can plug it back in here to check in the original equation, and they'll both work. All right. How can this get more complicated? Well, it can get a little bit more complicated. Let's suppose that we have one like this. Let's do 9 over 2 times x squared equals, and let's just say that's equal to 8. Okay, 9 halves x squared is equal to 8. There's a couple ways you could do this. You could multiply both sides by 2 and then maybe divide by 9. What I like to do is just get rid of the whole fraction. And the way you do that is you multiply by the reciprocal. So you have to have a good handle on fractions. Well, these two are going to cancel out because they're multiplicative inverses. They make 1. So I have x squared equals, okay, so here we go. 8 times 2 is 16. And then the 8 does not multiply by the 9. It's just 9 down in the denominator. All right, we can go ahead and do our square root property. And so I'm going to rewrite this so it looks a little bit better. We're going to take the square root here and the square root here, plus or minus, don't forget it. The x drops out. And now we have plus or minus. And we think about this, what two numbers, fractions, when you multiply them together in the same fraction, give you 16 over 9? Well, that would be 4 over 3, right? And you could also think about it like this. Root 16 is 4, root 9 is 3, and there's your fraction. This one, you don't have to move anything over because it's already all by itself over here. So the two solutions are just positive 4/3 and negative 4/3. So that one really isn't too bad, even though the original problem had fractions, you know, and we're all concerned about fractions all the time. But that one really wasn't too bad. All right, let's see one like this. Let's do x minus 1 squared equals, and let's do, I don't know, let's pick a number like 7, I guess. 7 sounds good. Now, the first thing I notice when I get one of these problems is that 7 is not a perfect square. So the answer I'm going to get is not going to be a nice rational number. It's going to be irrational, which is okay. It's actually going to be a little bit easier. This whole thing now is good to go. I don't have to move anything over. I don't have to divide by anything. I just go ahead and apply my square root property. Both sides, plus minus, don't forget it. The x minus 1 comes out, and that equals plus or minus the square root of 7. And by the way, you can't simplify the square root of 7. If you could, then you would want to simplify that square root. But this time, we really can't. All right, we do have to move the negative 1 over. So plus 1, and now x is equal to 1 plus or minus the square root of 7. And we normally just leave our answer like this right here. That's fine. You can't do anything with this. You can't add them. You can't subtract them. This one's irrational. This one's rational. They just can't be combined. So you just leave your answer just like this. All right. So let's do another one now that might have the same kind of issue here, but we might have to simplify the square root. So let's do this time. Let's get x, I don't know, plus 4. And then squared equals, and this time we're going to do, how about 20? Okay. Again, 20 is not a perfect square at all. So when I take the square root of both sides, I know that I'm going to get an irrational number over here. But it's okay. I've done enough of them. I can handle it. The x plus 4 is going to drop down. It's unlocked. Equals plus or minus the square root of 20. Now, it's always a good idea to take a look at this right here and see if you can simplify that. What is the square root of 20? Can you simplify that at all? If we take that square root of 20 and we make a factor tree, that would be, I guess we could do 5 times 4, right? 5 is prime, so I circle it. 4 is not. 4 is 2 times 2. Okay? A pair of factors down here is worth 1 on the outside. So really the square root of 20 actually is going to turn out to be 2 root 5. The 5 did not have a pair with it, so it has to stay underneath the square root again, right? Okay, if you ever have a doubt, you can always check these two numbers in the calculator. They'll give you the same exact decimal. It'll be irrational, but they'll be the same number. Okay, so here's what we're looking at now. X plus 4 equals, and now we have 2 root 5 over here, plus or minus 2 root 5. And college professors will actually take points off if you don't do that, if you don't simplify it. So you always want to, get in the habit of simplifying things, just like fractions. All right, we got to move the 4 over. So minus 4, 4's cancel, additive inverses. So x is equal to negative 4 plus or minus 2 root 5. Okay, if you looked in the back of a textbook, that's the answer that would be written back there, just like this. It wouldn't have a root 20 on there because textbooks wouldn't do that. They're going to simplify it. They're going to have the 2 root 5. But this is it. There's nothing you can do with this. You can't take the negative 4 and 2 and add them. You can't subtract them because the 2 is with that root 5. Okay, it's being multiplied by it. So you can't just pick the 2 off and do something with it. It's all or nothing. So this answer right here is done. And that's, at this level, about as hard as it's going to get with solving by square roots, unless you start putting fractions in there, which we're not going to do. So hopefully this video helps. Like and share. Let me know if you guys have any questions. Put them in the comments. And we'll be seeing you soon. Bye, guys.